Welcome back to the next episode of Blind 75 Leetcode problems. Today we are looking at the 11th problem, which is combination sum. What is the problem about? So we are given an array of distinct integers. So there are no duplicate values and a target integer target. Return list of unique combinations of candidates where the chosen numbers sum to target. You may return the combination in any order. The same number may be chosen from candidates an unlimited number of times. Two combinations are unique if the frequency of at least one of the chosen number is different. Okay. Okay, so it also states that there are test cases where the number of unique combination can is less than 150 for the given input. uh, okay, so yeah, let me take this. Yeah, okay, let's take a look at the example. So the candidate here is 2 3 6 7 and the target is 7. We need to create unique combination from these candidates and the same number can be used multiple times. So the combinations would be 2 plus 2 plus 3 and 7. So there are 2. We have to return list containing the combinations, right? Let's take a look at the next one. Here it is 2 3 and 5, target is 8. So we can do 2 plus 2 plus 2 plus 2 because we can use the same numbers multiple times, and 2 plus 3 and 3 plus 5. So there are 3 here. And this is another example where the candidate is 2 and the target is 1 and we cannot make it, so we return empty. So we have to keep in mind that the candidate length can vary from 1 to 30, and each of the values are positive, and it is between 2 and 40 inclusive. All the candidates are distinct and the target can vary from 1 to 40 inclusive. So looking at the problem, this looks like a backtracking problem where we need to try each of the combinations and find out the result. Let's see one example and see how we will solve this. Okay, we can use say the first problem, which is 2 3 6 7. Let's start with an empty list, which is the unique combination. Here I'll take 2 to the add 2 to the list, then I'll add 3. So I'm trying each of the element. We don't want duplicates, right? So what we'll do is we'll pick each of the one and then start picking the rest of the element including the same one. For example, so here, so we have picked 2 already, so I can pick 2 again, right? So I'll pick 2 3 6 7. We'll only pick if it matches with the target, and if it is more than target, then we won't. So that is the pruning like stopping condition. Okay, so here the target is equal to I'm mentioning it as t equal to 7. So for example, here it is 2 plus 7, right? So I'm considering the 0 1 2 3 third index element, which is 7. So it becomes 9, right? 2 plus 9. So we won't consider this also we won't consider, and so on. So that is how we prune it, right? So here we have considered 3. In order to avoid duplicate, we will only look at the numbers starting from that particular index. So here we will consider 3, 6 and 7. And here initially we are considering 6, then we will consider that element and the next element only. So 6 and 7. Then we'll start with 7 in the combination and we'll check with 7. So this way we can avoid duplicate. What would happen if we add here 2? Then it will become 3 plus 2, which is equal to 2 plus 2 comma 3 here, right? So that is why we don't do it. I hope this is clear. Okay, so let's see. 0, 2 and 2, right? So the list is 2 plus 2 here. Here it is this 2 and the next element 3 here. We will stop the other because the sum is 8 and here sum is 9, so we won't consider it. So here it is going to be 3 comma 3. We'll consider it because the sum is less than 7. We won't consider this. We won't consider this. This is still less than target, so we'll consider this, but we'll stop here because the sum becomes 13. We will stop here, right? And we have this 7, right? So we add this. So there are two conditions we use during backtracking to so one is when the sum of the combination becomes 7. So this is one such use case. And the other one is we have to stop adding or stop iterating when the sum is greater than 7. So these cases, right? So here this is still less than 7, so we'll go ahead again with 2, 3, 6 and 7. So 2 plus 2 plus 3, right? 2 plus 2 plus 2. So this is 6. Here we get 2 comma 2, which is from the previous iteration, and 3. This is 7, right? So we got this. So we'll add this to the result. We will also add this to the result. Okay. And here it is greater, so it will stop here. It will stop here. This will again run to say 2, 3, 6 and 7. So 2 plus 2 plus 2 is already 6. 6 plus 7 is 13, greater than 7. This is 6 plus 6, 12, which is greater than 7. This is 6 plus 3, greater than target, which is 7. Here it is 2 plus 2 plus 2 plus 2, which is 8. Again, so it will stop here. So this is one way of doing or computing the solution. And let's see how we can implement it. Okay. So okay, so let's see how we can implement it. Okay. So so what we have here is we need to write a backtracking. Okay, let's see. We'll store the result in an array, which is the outer array, and we'll add the combinations to this results as we go about it, like when the sum reaches 7. Okay, so let's do I'll name this function as backtracking. What I'm going to do is, instead of summing up, we can do it in either way. Okay, let's do total and combination comma index, right? If total is equal to target, that means we have found a combination. So we'll do results dot append of combination. We do it because in Python combination actually holds the reference and each iterations it changes. So we need to create the copy of the combination. Otherwise everything is going to be same at the end of the day. So yeah, and we will return if total greater than target. That means it has crossed whatever was the target. So we'll return. We won't do anything. So we will not continue iterating. Okay. So the ID is the starting ID. So what we will do is we'll for I in range of ID. It has to start from here, and we'll do until the length of the candidates, right? And what we'll do is combination. We'll add it to the combination of append of candidates of I, and then we'll keep trying, right? So we'll backtrack with what the total is going to be total plus candidates of I, right? And we'll send the combination, and we'll do idx oh yeah, here it is I, and we need to remove it for the next iteration to go, right? So what we'll do is combination dot pop off. Okay, let's how do we call this method? Backtrack total, let's start with 0, and combination will be a list, and start or the idx is again the starting index, and we will return. Now the results should have the combinations, right? So let's try running this and see if it is yeah, working. Okay, so it has worked, right? Let's try submitting it. Yeah, okay, so it beats 61.44% of users. Is there a different way to solve this? Yes, there is actually. So for example, we can use dynamic programming to solve this. If you notice here, we kind of if it is a bigger number, for example, uh, we don't care about the targets greater than 7, and what we need to find out is the combination leading to the sum of target, which is 7 in this case. Okay, so if I had to take an example, okay, let's see. Let's take another example. I hope this is the right one and I can tell you how yeah, so we have 3 4 5 6, and say the t is 15. Okay, so if you yeah, let's write this sums, right? So 3 plus 4 plus 3, which is 10, right? 4 plus 3 7, 7 plus 3 10, then 5, this is 15, then 5 plus 5 plus 5, I meant comma here. Okay, this is again 15. Can we find the sub problem here? So if we know the combinations for say 10, here those are this 3 plus 4 plus 3 and 5 plus 5, then if we have 5, we can just loop through the combinations and add 5 to it to make it 15. There is another combination actually, which is 6 comma 4. So this is again another combination, then if we add 5 to it, it also becomes 15. So what we are trying to do is, we will build the sub problem. For example, we start from the maybe smallest number, and then create a dynamic programming array where we fetch the combinations that makes up to 3, then 4, then 5, and so on until 50. So in this case, the DP would contain 3 for 3, and 4 for target 4, and 5 for target 5, 6 for 6 and 3 comma 3 for 6 target, and so on. So we'll keep building until the target, and at the end what we would get is, we will get the entire result. Okay, so let's yeah, so that is something that we can do. Let's see how we can implement it. Okay. Okay, so let me define a DP array which is empty 4. I'll add it for, say, target plus 1. Okay, and we'll iterate through the candidate. For C in candidates, we'll take each of the element, and what we'll do is, we will find the combinations leading to that particular C. For I in range of 1 comma target plus 1, if the I value is less than 3, that means we cannot do anything about it. If I is equal to C, so we know that DP of I is that particular element. So the examples are 3 and 4. Else, what we will do is, we will take a look at the previous sub combination. In, if you take this example, this list 1, 2 and 3, which leads up to 10, and then add our candidate, right? So what we'll do is, for combination in DP of I minus C, so we are taking the 10 value here as an example. Then what we will do is, DP of I dot append of combination plus C. So if you take a look at, this is the C here, 5 is the C here. So what we are doing is, we are checking the combinations in DP of 10, and then adding 5 to each one of them, and updating the DP of 15 here. Okay, so so what we are doing is, DP of I dot append of combination plus C, and at the end what would we have? We will have the entire target, right? So let's return that. Let's try running this. Okay, there you go. So this is another way of solving it, using dynamic programming, where we find the sub problems and use it to calculate the combinations which add up to the target. So we start with a array here, where we find say combinations leading up to each target. So there is one way to optimize. Instead of doing it here, if you see, we are doing it from 0 to, say, target plus 1. So if the target was 15, we will add we'll have a DP of length 15, right? So we can also do something like minimum value of candidates here. Like so here we cannot do anything other than that, right? If we had 3, 4, 5 and 6, we can make combination starting with 3, so we can actually do like this. So that is a minor optimization that we could do, and that's it. Okay, so let's take a look at the complexity here in the dynamic programming. Okay, uh, so this, if you think candidate, the length of the candidate is n and target is m, and the worst case this is again m, then what we'll do is the time complexity is order of n into m. Okay. uh, what is the space complexity? we are we are using DPRA, right? So what would be the complexity? So the complexity is going to be order of m by m, right? So where m is the target. That's it. Let's try submitting and see if we pass all the test cases. It beats 99%. So this is one of the best solution. Okay, so that's the end of this episode, and we have completed 11 problems from line 75. I'll be back with the 12th problem soon, and if you like this video, please consider subscribing. Please let me know if you have any feedback, and also let me know if you find any mistakes or if you didn't understand any part of the video. So see you again in another video. Thank you so much, and take care. Bye bye.